In this video, we are going to learn about logarithms. So in the description below, you can click on the link to download the worksheet, which allows you to do the examples together with me, or you can use it as your revision notes before your exams. So let's get started. But before I introduce our friend logarithms, we need to recall our index forms or indices first. So in indices, we learned that there's a function y equals a to the power of x. So a is known as the base, which is the rock at the bottom, and x is the power on the index, which I like to see as a kite attached to the rock. So an example of an index form will be 1000, which is y equals to 10 to the power of 3. 10 times 10 times 10. This is a quick recap. So special index forms that you need to know is a to the power of 1 equals to a, which means that if I have a number, any number, to the power of 1, I will get back the same number. If I have another number, 200, to the power of 1, I'll get back the same number, 200. If I have 1, 3, 4, 2, another random number to the power of 1, I'll get back the same number, 1, 3, 4, 2. So this is a special index form that we need to know. Another special index form we need to know is a to the power of 0 is always equals to 1. So for example, 100 to the power of 0 is 1. 200 to the power of 0 is also 1. 1, 3, 4, 2 to the power of 0 is also 1. So our new friend logarithm, or in short we call it log, is another way of expressing our index form. So in index form, it's a simple y equals a to the power of x. So if we express it in the log form, we will see the word log, L-O-G, with a base a, y equals to x. The base here is the same rock in the index form. The kite has now come out to the front. So in summary, our log form will be log to the base of a, y equals x. For log ay to be defined, or rather, if you want to have an answer in log ay, you need to fulfill two criteria. The first criteria is your y has to be more than 0. And your second criteria is your a, which is the rock, has to be more than 0 and it cannot be 1. So let's look at the example. In index form, we write 1000 equals to 10 to the power of 3. So when we introduce log in, the rock becomes the base to the log. 1000 is my y here, and my kite, my index, is now outside. So if we look at 100, which is equals to 10 square, to write it in log form, we write log first, and then my base is 10, which is the rock. 100 equals to 2, the kite, which is the index. So if you ask me what is log for, log can be used to find the power in an index form. So let's look at some special log forms. So earlier on we saw two special index forms, number 1 here and number 2 here. So if I convert number 1 to log form, it will look like this. Log base a, and I'm logging the a, the same number, equals to 1. So this a came from here, which is the base, and 1 is the kite, the index, right? So which means to say, if I have log base 5 and I log 5, my answer is 1. If these two numbers are the same, my final answer will always be 1. Let's look at the second special index form. A to the power of 0 equals to 1. When I convert it into log form, I have the base here, the rock, okay, the power is 0, so it's here, and my 1. So if I log 1 with any base, for example, it could be maybe 2. As long as I'm logging 1, my answer will be 0. Earlier on, you saw log, L-O-G. But what happens when you see LG? LG is actually short form for log to the base of 10. So earlier on, we saw that 10 squared is equals to 100. If we change to log form, it will be log, log, base 10, 100 equals to 2. Or it can be written as lg 100 equals to 2. So in another example, 10 to the power of 3 is equals to 1000. To change this to log form, it will be log base 10, 1000 equals to 3. So in common log form, or we can rather write it as lg 1000 equals to 3. Another log that we need to know is the natural log. So the natural log is derived from y equals to e to the power of x. So e is the base, which is here, and x is the index, the kite, which is on the outside in the log form. So log base e y is equals to x. So to write it in the natural log form, we will have ln, which is written like that, like a letter L, and n, y is equals to x. So don't be afraid when you see ln y equals to x. It basically means log base e, y equals to x. So we need to know a special ln, a special natural log. So when you see ln e, it actually means log base e, e is equals to 1. So remember earlier on we have a special log. If these two numbers are the same, the final answer will be 1. So here's a summary of the common log form and the natural log form. For common log form, the base is 10. For natural log form, the base is e. Now we'll dive right into 4 questions. The challenging part about log is you have to figure out which formula to use. So I have actually put up the formulas that we need to know. So we are going to identify which formula we should be using for the question. So for question 1a, given that log base 4x is equals to 2 and log base 2y is equals to 3, evaluate x over y. So I need to get out my x from the log form and I need to get out the y from the other log form. So in other words, I will have to change these two logs into the index form. So I'll start with log base 4, x is equals to 2. So this is my base and this is my kite, right? So my base here, my kite on top, will be equals to x. So this is a very easy change to the index form. So as for the other log base 2y equals to 3, same, my base is 2, my index is 3, so I put my base at the bottom, my index, my kite at the top, equals to y. So in other words, my x is equals to 16 and my y is equals to 8. So x over y will be equals to 16 over 8, which is equals to 2. Right, now let's look at another question. Given that log base x a is equals to 1 and log base y b is equals to 2, express xy square in terms of a and b. So I need to know what is xy square. And I have two log forms here. So basically I will need to tease out my x from here, and I'll need to tease out my y from here. So what I have to do is I need to change the log form to index form. So starting with log base x a is equals to 1. My base is the x. My index, my kite is here 1. So base kite is equals to a. So log y base yb is equals to 2. This is my base and this is my kite. So my base, my kite is equals to b. I hope I'm not confusing you by saying base and kite, because actually that's how I look at, or that's how I try to help myself to remember. Another way of looking at the kite is just simply call it the index. So then we have x is equals to a and my y square is equals to b. And this is perfect because the question is asking for xy square. So replacing x with a and replacing y square with b, my final answer will be ab. Now let's look at question 2. Without using a calculator, evaluate this complicated looking fraction. It's not complicated at all after you break it down and realize that we are actually looking at special logs. So 3 log base x plus 2 over 4 minus 2 log base 5, 1, and this whole thing is squared. So we are actually staring at two special logs here. This log here and this log here. If you remember earlier on, we went through two special logs. So if I have log base x, as long as these two are the same numbers, they will get me 1. So the other special log that we went through is also log whatever base I get. As long as I'm logging 1, my answer is always 0. So now let's put this back into the question. Equals 3 log base x will give me 1 plus 2 over 4 minus 2 log base 5, 1, and well, because I'm logging 1, I'll be left with 0. So now I have changed all my log forms to numbers. So on top, 3 plus 2 is 5. Below, 4 minus 0 is 4. And this is squared. So my final answer will be 25 over 16. Question 3. Convert algae x minus y is equals to square root 2 into index form. So this question is testing you on your knowledge of the common log. So when we see algae, it means log base 10. And we are going to log x minus y, which is equals to square root 2. To convert a log form into index form, we must always identify where's the base, our rock, and where's the index, our kite, which is on the outside. So this is our base 10, and our kite, our index is square root 2, is equals to x minus y. So this is the index form. So the thing about log and index form is you need to know how to change them interchangeably. So currently what we are doing now is to change the log form to the index form. When we get the index form, how do we change this to the log form? You must always identify where's the base and where's the index. Where is your rock and where is the kite? So changing back to log form, I have log, my base is 10, my index is on the outside, which is square root 2, and whatever is here will be behind my log. Question 4. Solve log base x 4x minus 3 in bracket equals to 2. So to do this question, we have to change it to the index form first, and we'll slowly tease out the x to find out what is x. So let's change it to the index form first. Log base x 4x minus 3 in bracket is equals to 2. My x is the rock, the base. My 2 is the kite, which is the index. So I'll have x squared is equals to 4x minus 3. Looks like we have a quadratic equation here. So x squared is on the left hand side. I'll keep it on the left hand side. 4x minus 3 is on the right hand side. So to shift it over to the left hand side, I will have to change their signs. So 4x will become minus 4x, and minus 3 will become positive 3 equals to 0. So I will have to factorize this quadratic equation. To get x squared, I'll have both x's here, and to factorize my 3, I'll have 3 and 1. To get negative 4, I'll have to put both signs to be negative. So usually after I factorize my quadratic equation, I will do a quick check. So x times x gives me x squared. X times negative 3 gives me negative 3x. Negative 1 times x gives me negative x. Negative 1 times negative 3 gives me positive 3. So in summary, I have x squared minus 4x plus 3, which means my factorization is correct. So back to solving my x. Then I'll have x minus 1 equals to 0, or x minus 3 equals to 0. So my x is equals to 1, or my x is equals to 3. Now I have two answers here. The thing about log equations is that you have to check whether the answer will be able to define my log base a y. So for my log base a y to be defined, there are two criteria to fulfill. So the first criteria is that my y has to be more than 0, or rather, whatever that I'm logging, it has to be more than 0. The second criteria is that my a, which is the base has to be more than 0, or it cannot be 1. So if my x is equals to 1, my log base x, which is 1, will become 1. 4x minus 3 will become undefined, as the base is 1. So I will have to reject x equals to 1. So my final answer will only be x equals to 3. Now that we have looked at the different forms of log, we shall move on to the 4 laws of logarithms. We will start with the power law. Why is it called the power law? It's because we are going to identify the power in the log form, and we are going to manipulate it. So what we see here is log base a, x to the power of r. So our power is r. So in the power law, it's stated that we can actually bring the power to the front, and we'll have log base a x. Let's look at an example. So evaluate without using calculator, log base 2 8. So I have log base 2 here. Okay, and I can change my 8 to 2 to the power of 3. Why did I choose 2? It's because later I can bring the power to the front, and I'll be left with log base 2 2, which is a special log form to make it 1. So bringing the power to the front, I have 3 log base 2 and log base 2 2 will give me 1, and I have my 3 in front, so 3 times 1 gives me 3. So now let's look at the second law, the product law. So in the product law, we know that with the same base, log base A, log base A, log base A, we can actually split out the product x and y, okay, by adding them together. So let's look at an example. I have two examples here, example A and example B. We'll start with example A. So in example A, we notice that all the logs here have the same base. They are all added together, so I can make use of the product law. So I'll put them in the same base. Okay, this is my x, this is my y, and my additional z. So I can actually multiply them together. 40 times 0.1 times 0.25. Okay. So from here I can use the calculator to find out the answer. But what I'm going to do is I just use a fraction. I'll cross multiply. This 1, this 4, this 1, this is 1. So actually at the end of the day, I'll be left with 1 whole. And we know that if we log 1, we will get 0. So let's look at example B. We have log base 2 to square root 2. So what we have to identify is the base here, so that we know how to split this up. So since my base here is 2, I'm going to split up in this way. 2 times square root 2. Using the product law, I'm going to split them up. Log 2 plus log base 2 square root 2. Okay, so I'm going to tease out the power in my square root 2. Log base 2 gives me 1. Okay, and using the power rule, I'm going to bring the power to the front. Log base 2 give me 1. So my final answer will be 1 plus half, which will give me the answer 3 over 2. Okay, now let's look at the quotient law. So the quotient law is like the product law, just that instead of x multiplied by y, we see here x divided by y, and all of them share the same log, same base. Okay, x is in front again. Instead of plus, we get the minus sign, and then y is at the back. So let's look at an example. Evaluate without using calculator log base 6 54 minus 2 log base 6 3. So this question here has the same base to the log, and you see a minus sign. So this gives us a clue that we can use the quotient law. So let me write this down. Log base 6 54 minus 2 log base 6 3. Okay, so I have a problem here. My 2 is not behind my log, so I am going to use the power law and put it as a power. So log base 6 54 minus log base 6 3. My 2 becomes the power, so it becomes 3 squared. So now I have log base 6 54 minus log base 6 3 squared. So I can take my 54 as the x, and I can take the 3 squared as my y. So putting them together using the quotient law, same base, x goes on top, y goes below, so it's 54 over 3 squared. So I'll get log base 6 54 over 3 squared or rather 54 divided by 9 is 6. Since these two are the same number, the special log form tells us that they are equals to 1. Final answer. Now let's look at the fourth law, which is the change of base law. So this is a very powerful law as it allows you to change the base to the log. So for example, I have log base A, B. Okay, A is the base and I would like to change it to C, for example. So I have a fraction here. I'm changing base A to base C. And now my B here will be in the numerator and my A here will be in the denominator. So for example, if I have log base 2 at 5, okay, and I would like to change the base to maybe 3. Okay, so my 5 go on top, my 2 will go below. So this as simple as that. So what you need to know is how you express it, okay, in a fraction, and which one should go on top and which one should go below. Okay, so another useful thing that you would like to know is if I have log base AB and I want to have a simpler fraction, meaning a whole number on top. This is a kind of a trick. So I can actually change the base to B, which is the same number as the number that I'm logging. So log base B will give me 1, and then log base B, A, which is the A from here, will be at the bottom. So instead of having a log over another log, I will have 1 over log B, base B, A. Let's look at an example. So this question is to convert log base 5, 7 to common or natural log and find its value. So let's do a recap. Common log is log base 10, right? And we write it as LG. Natural log is log base E, and we write it as ln. Okay, so let's convert log base 5, 7 to common log first. So common log is base 10. So I write this down first. A fraction, log 10, base 10, log base 10 at the bottom. 7 goes on top. 5 goes below. Okay, so in short, it is LG 7 divided by LG 5. So if you key in your calculator, I have a calculator here, log 7 divided by log 5. I will get 1.20906. And if I correct it to 3 significant figure, I'll have 1.21. 3 sig fig. Okay, now let's look at the natural log and see if we get the same answer. So natural log means my base is E. So same question, log base 5, 7 is equals to log base E. Log base E. Okay, 7 goes on top, 5 goes below. So writing it in natural log form, I have ln 7 over ln 5. Now I'm keying in my calculator, ln 7 divided by ln 5. I will get like the same answer, 1.20906. Correcting it to 3 sig fig, I'll get 1.21. Magic. Okay, so now that we know all 4 laws, let's look at 4 different questions that test us on all the laws. The difficult thing, or rather the challenging thing about logarithms is that you need to look at the question and you need to figure out which law you can use to solve the question. So let's look at this. Evaluate ln 4 over ln 32 without using a calculator. So good thing is they share the same base because they are both log base e. Okay, that's the meaning of ln, right? Okay. We would tend to look at the quotient law because you see a divide sign. But if you notice in the quotient law, I only have log base a, okay, and the quotient is here. But this question is actually a log divided by another log. So that means the quotient law is out. But what I notice is that 4 and 32 will have the same base. What do I mean by that? So let's look at this. Ln 4, ln 32. So for log, it will be good to be quite sensitive to the numbers. If you look at 4, I can actually change it to 2 square, right? And if I look at 32, I can change it to 2 to the power of 5. 2 to the power of 5 is 32. Okay, so now I can make use of the power law. I bring down the power, ln 2 over 5 ln 2. Now I have ln 2 here, and I have ln 2 here, and I can cancel each other out since they are in a fraction. And 2 over 5 will be my final answer. Question 2. Express 1 plus 2 log base 3 5 minus log base 3 1 over 27 as a single log. So this gives me a very big clue that I have to change all of them to the same base. So now my problem or my challenge is this one whole here. How do I change it to have the same log, same base? So what is this number? So to make this one whole, this number here and this number here has to be the same. So I'll have log base 3 3 plus 2 log base 3 5 minus log base 3 1 over 27. Okay, so now my 2 is in front of my log, so I'm going to shift it into the log by using the power law. So log base 3 5, my 2 come over here to be the power minus log base 3 1 over 27. Alright, so now I have 3 logs with the same base, and they are all separated by a plus sign and a minus sign. So this tells me that I have to use the product law here, and this tells me that I have to use the quotient law here. So I put my log base 3 down. Okay, so 3 and 5 square will be on top, and they will be multiplied by each other because it is a log plus log. Okay, and 1 over 27 here will be at the bottom in the denominator using the quotient law. Okay, so let me repeat that. 3 log base 3 plus log base 3 5 square is at the top with a multiply sign, and then because of this minus sign, I'll use the quotient law. So this whole thing minus this, so this one goes to the bottom. Okay, so I have log base 3 times 5 square gives me 75 divided by 1 over 27. So if I key in my calculator, 75 divided by 1 over 27, I'll get log base 3 2025. Question 3. Express y in terms of x. So I have common log y plus 1 equals to 2 minus half common log x. So the thing about this question is we have a little problem here because this is not in log form. So we'll probably have to change it to log form. Okay, so let's do that now. I have log, common log y plus 1 equals to this, which we need to find now, minus half common log x. How do we change 2 to a common log? So common log is log base 10, right? And now this number here is an unknown. And how do we find this number? We have to use the index form. So the index form we'll need to identify the base, and we'll need to identify the kite, which is the one on the outside. So my base is 10 and my kite is 2, so my number is 100. So this is 100. So I change 2 to common log 100. Okay, so here my half is outside, is in front of my log, so I'm going to shift it into the log. So common log y plus 1 equals to common log 100 minus common log x to the power of half. This is the power law. So then I have y plus 1 here, I have 100 here, and I have x to the power of half here. Okay, and all of them share the same log, which is the common log. So I will look at this first. These are two logs that are separated with a minus sign. So this tells me that I can use the quotient law to put them together. So I have common log here. Okay, 100 goes on top, and x to the power of half goes below. So log 1 plus 1. So since they are the same log, the same base, it means that y plus 1 is equals to 100 over x to the power of half is square root x. Okay, and this, oh wait, we need to express y. So we need to bring over the 1. So y is equals to 100 over square root x minus 1. This is the final answer. Okay, question 4. Given that log base 4 3 is equals to a and log base 4 5 is equals to b, express log base 75 16 in terms of a and b. Okay, so this question is quite obvious that we have to use this law called the change of base law. Why? Because I have log base 4 here, I have log base 4 here, okay, but I have log base 75 here. These are all different. This is different from the rest. Okay, so let me change it up. Log 75 here first, 16. Okay, so the change of base law tells me that 16 will go on top and 75 will go below. Okay, so what would be a base that you want to change to? 1, 2, 3, 4. You can change to any number, but let's look at the question. The question gives you the value, or tells you that a is equals to log base 4 3 and b is equals to log base 4 5. So I would most likely need to use base 4. So I'm going to change the base to 4. Okay, so now I have log base 4 16. Okay, and I have log base 4 75. I will need to change log base 4 maybe to the same number here, because log base 4 give me 1, right? So I will have a 2 here. So I change log base 4 16 to become log base 4 square. Okay, and my bottom, log base 4. How should I change the 75? 75 is 3 times 5 times 5, right? And I can actually use this log base 4 3, and I can actually use this here log base 4 5. Okay, so now let's use the power law to break down the numerator. So I bring down the power to log base 4 4, okay, over, okay, so since I have many multiple signs here, I'm going to break them out using the product law. So I have log base 4 3 plus log base 4 5 plus log base 4 5. Okay, running out of space here. So log base 4 4 is 1, so my numerator is just 2. Log base 4 3 is a, so I'll replace it with a. Log base 4 5 is b, so I'll replace it with b plus same thing b, and my final answer is 2 over a plus 2b. Let's move on to the next part of logarithms, which is solving log equations. To solve log equations, I can use two ways. The first way is the law for the same base. So it states that if I have two log forms equivalent to each other, so I have this log here, I have another log here, they have the same base, okay, different values here, it means that my m is equals to n. Let's look at the question. So solve log base 3, x plus 3 equals to log base 3 x plus log base 3 x minus 1. So I have all logs with the same bases here, so I can make use of the law for the same base. Okay, so I'll write this down first. Okay, on the right hand side I have log base 3x plus log base 3 x minus 1, which is good because they have the same base, right? So I can make use of the product law. So a recap to the product law, log base a xy, this is the product, equals to log base a, same base, x plus log base a y. So I can actually simplify x and y in this manner in a product. So log base 3, put them together, I have x multiplied by x minus 1. Okay, now my left hand side and my right hand side have the same log, same base, so I can get rid of them. I'll be left with x plus 3 equals to x times x minus 1. Expanding this out, x plus 3 equals to x squared minus x. I'll put them together on one side, so x squared minus x minus 3 equals to 0. Simplifying this, x squared minus 2x minus 3 equals to 0. I have to factorize this. So x to give me x squared. 3 can be factorized to 1 and 3. Okay, I'm going to put the minus sign at 3 and the plus sign at 1 so that it can give me negative 2x here. So my x is equals to negative 1 or my x is equals to 3. I have two answers here, so I have to be careful. So I need to see if I need to reject any answer, which happens to be x equals to negative 1. Why? Because if I put x equals to negative 1 into here, so my log base 3x will be log base 3 negative 1, which is undefined. Because I cannot log a negative number. So I have to reject negative 1. Okay, I'm running out of space here, bear with me. Okay, so my final answer will be x equals to 3. So now let's look at the second law, change of base law. So the change of base law is to change my base, right? So when do I need to change my base? Let's look at the question. Solve log base 3x minus log base x 3 to the power of 6 equals to 1. So in this question, you'll notice that they have two different bases. So this tells me that I have to use the change of base law. So I will keep the one with the number. Okay, I will change the base x. And what number should I change to? Let me look at what I have. So 3 to the power x will be in the numerator and x will be in the denominator. So my base, I will choose 3 because if I have 3 here and if I have 3 here, okay, log base 3 will give me 1. So it will simplify my equation further. Okay, so let's simplify this. Log base 3 will be 1, but before that let's use the power law first. I'll bring forward my 6. Okay, my log base 3 over log base 3 x equals to 1. Okay, so log base 3 x minus 6, this is 1 over log base 3 x equals to 1. I have log base 3x here. I have log base 3x here in the denominator. What I'm going to do is I'm going to let y equals to log base 3x. So then my equation will become y minus 6 over y equals to 1. Which will make things look a bit cleaner. And then we will replace the y with log base 3x later on. So then, to get rid of this fraction here, I'll multiply each term here with y. So multiplying by y, I have y squared minus 6 equals to y. Okay, looks like we have a quadratic equation here. So I'll put them all to one side. Y squared minus y minus 6 is equals to 0. Factorizing this. Okay, I have my y and y here to make it y squared. Okay, so the last number is 6. So I can either do 1 times 6 or 2 times 3. I'm going to choose 2 times 3 because my y here is negative 1. So by adding or subtracting 3 and 2, it will give me 1. Okay, I will put my minus sign at my 3 and my plus sign at 2 so that it gives me negative 1. Okay, so I'm going through this very fast because this belongs to another chapter, the quadratic equation chapter. So y equals to negative 2 or y equals to 3. Then I'll bring back my log base 3x, which is equals to negative 2. Okay, I'm replacing the y with log base 3x. Okay, same thing here. Okay, so how do we solve this? We have to change this to the index form. So let's just do a little recap. This is my base and the number on the outside is my kite, right? This is my base. The number on the outside is the kite. So putting it to index form, my base at the bottom, my kite at the top equals to x. My base at the bottom, my kite at the top, which is equals to x. So my x is equals to 1 over 3 squared, which is equals to 1 over 9. Or my x is equals to 3 times 3 times 3, which is 27. Okay, so let's look at another question. Solve the simultaneous equations ln 3x minus y equals to ln 36 minus ln 9. So that is the first equation. And e to the power of x squared over e to the power of y is equals to e to the power of 1. So this is the second equation. So I'm going to simplify the first equation First, let's look at this here. Okay, they have the same log, same base, because ln is log base e, right? Okay, so this one looks like we can make use of the quotient law. A quick recap, which is log base a x over y is equals to log base a x minus log base a y. Okay, so to put them together, I will have ln 36 over 9. Okay, so since the both of them is the same log, same base, that means my 3x minus y is equals to 36 over 9, which is 3x minus y equals to 4. Okay, now let's look at the second equation. Second equation, I have ex in bracket square over ey. So I'm going to simplify that. So e 2x over ey equals to e to the power 1. Okay, so this is in the indices chapter. So if I have am over an is the same as am minus n in the index. So this is e2x minus y. So in a quotient, I minus the powers, or I minus the indexes, equals to e1. So since they have the same base, 2x minus y will be equals to 1. Okay, and this is 3, this is 4. Okay, so I'm going to use y here, 3x minus 4. Okay, I'm going to sub it into my equation 4. So I have 2x minus 3x minus 4 is equals to 1. Okay, and then when I simplify this, 2x minus 3x plus 4 equals to 1. My x will be equals to 3. And this tells me that my y will be equals to, if I sub in here, okay, 3 times 3 is 9, 9 minus 4 is 5. So previously we saw how to solve log equations. Now we look at how to solve equations of the form a to the power of x equals to b, which is the index form. In indices, we learned that if the bases are the same, okay, the powers will be the same too. So if I have a to the power of x equals to a to the power of n, the power x will be equals to the power n. So for example, solve 4 to the power of x minus 1 equals to 2 to the power of 2. So I'll make them into the same base first. So I have 2 square, which is my 4, x minus 1 equals to 2 square. So since they have the same bases, that means their powers are the same. So 2x minus 1 is equals to 2. Okay, so I expand this out. I have 2x minus 2 equals to 2. Bring my 2 over, I get 4. And my x is equals to 2. Okay, but for equations that cannot be expressed to the same bases, apply technique of taking logs on both sides. So just now I can actually express my 4 to 2 square, right? To make the base the same as the one on the right hand side. But now let's look at another question. Solve 4 to the power of x minus 1 equals to 9. I cannot change 4 and 9 to the same base. There's just no way. So what we have to do is we have to take common log on both sides. So common log, a recap, is log base 10. Why we choose common log? Because we can type it in the calculator to get a value. So I'll log both sides. Alright. Okay, I have a power here. So using the power law, I bring down the power. I have log 4 equals to log 9. Okay, So don't be afraid of log 4 and log 9. They are values if you key in the calculator. So I'm going to bring in the values to the same side, equals log 9 over log 4. Okay, I'll then have log x equals to log 9 over log 4 plus 1. And when you key in the calculator, I will have 2.58496. So correcting to 3 sig fig, I'll have 2.58. Okay, now I have a question. Solve 2 to the power of x plus 1 equals to 3 to the power of x. So this is an index form equals to an index form, and they have the bases 2 and 3. However, we cannot change them to the same bases, so we have to take common log on both sides. So taking common log on both sides, I will have LG 2 to the power of x plus 1 is equals to LG 3 to the power of x. Using the power law, I will bring down the power. So I have x plus 1 multiplied by LG2 equals to x multiplied by LG3. Okay, don't be afraid of LG2 and LG3. These are values that I can find out from the calculator. So I'm going to put them on the same side. Okay, why is LG2 in the denominator? Because this is x plus 1 multiplied by LG2. So when I bring it over to the right hand side, it becomes divide. So same goes for the x's. Okay, now that I have a value here on the right hand side, I'm going to key in the calculator to find out what is it. So the calculator tells me that it's 1.5849. So x plus 1 over x is equals to 1.5849. Okay, so 1.5849, bring over the x will be multiply. Okay, I'll bring all the x's over to one side. Okay, so 1.5849 minus 1 will give me 0.5849 x. Okay, so I'll use the calculator to divide 0.5849. I'll get 1.7096, which is 1.71 corrected to 3 sig fig. Okay, so now we are at the final part of logarithms, which is graph. Okay, so for a graph of y equals to log base ax to be defined, so this is the same two criteria that we mentioned earlier. My x has to be more than 0. Okay, whatever we are logging has to be a positive number. And the base, which is a, has to be more than 0 and it cannot be 1. So there are two forms of log graphs. One is when a is more than 1, and the other one is when a is between 0 and 1. So for example, if my y is equals to log base 2 x, this is when my a is more than 1. Okay, my graph looks like this. So I usually start from the bottom, okay, and it goes up like that. Okay, so it looks almost like a straight line here because this is approaching the y-axis. Okay, but we will never hit the y-axis. Okay, and it goes up and it has to cut my x-axis at 1. Okay, and it goes up. So this is my y and this is my x-axis. Why is this 1? Because for my y to be equals to 0, okay, whatever the base is, I have to be logging 1. Okay, let's look at the other log. So the other log graph is when my a is between 0 to 1. Okay, and remember my a cannot be equals to 1. Okay, so for example, if the base is log base 0.2x, my graph will go down the other way. Okay, so it's like a reflection. This line here, okay, is almost straight on top and it goes down like a slide. Okay, and you have to remember it cannot hit the y-axis. Okay, so it goes down like a slide and it will cut the x-axis at 1, 2. Why? Because when my y is 0, okay, whatever the base is, I have to be logging 1. Okay, my question here, y equals to log base 1/4 x. So this 1/4 will make my base in between 0 and 1. So that means my graph will look like the slide going down. Okay, so I will start from the top, almost like a straight line, and it cuts the x-axis at 1. Okay, question 2. Y equals to common log x. So common log x means my base is log base 10x. So that means my base is more than 1. So I will be drawing the log graph like this. 1. From below, go up, cuts the x-axis at 1, and there we have it. Okay, final question. Y equals to ln x. So a recap, ln is y equals to log base e x. So if you key in the calculator to find the value of e, you can key in e to the power of 1, you will get 2.7182. E is 2.7182. So which means to say that my a is more than 1. Okay, so for base a more than 1, my graph will be going upwards again. So it cuts the x-axis at 1. So this is the graph. We have come to the end of the topic logarithms. Hope this has been helpful. See you in the next video.